First experiment is exploratory data analysis and data pre-processing. First, we load the data set that is stores 1A, and then to find the number of columns and number of rows for the first question, I used df dot shape of 0 to find the number of rows and df dot shape of 1 to find the number of columns. Coming to the second question, this to find the number of categorical and numerical columns. And for finding the categorical columns, I used select d types and include objects, which finds the categorical columns, and to find the numerical columns, include entry.number and in select data type. And finding the length using len function, you'll get the number of categorical columns and numerical columns. The question is to display the min, max, and mean. I use .agg of min, max, mean of the numerical column, and that will be the output of the same. And coming to the fourth question, it is a 5 summary plot for age column and correlate with a box plot. So for the finding the 5 number summary, I used the describe function, and within that I printed the minimum 25%, 50%, and the third quartile and the maximum value out of it, and then the correlation is shown in box plot, which shows the 5 summary plot. Coming to the fifth question, display the row index along with the outlier values for the column quantity using IQR and verify with box plot. Find the IQR first using the formula Q3 minus Q1, and then find the lower bound and the upper bound. Again using the formula, which is for finding the lower bound is Q1 minus 1.5 into IQR, and for upper bound it's Q3 plus 1.5 into IQR. And then find the outliers, which is outside the lower bound and the upper bound, so which is given in this graph. So these are the outliers quantity. And coming to the sixth question, display the row index along with the outlier value in Z-score for the column quantity and verify with box plot. So here I taken 3, which means most of the outliers will be having the Z-score greater than 3, and that's it. In the box plot for presenting the outliers. And then coming to the seventh question, the correlation for the input features of age, price, tax, and quarterly tax and rating, and setting a variable with all these values, and finding it using the function called CORR function, which returns the correlation of all the input features that is taken before. And coming to the eighth question, it is to display the feature pairs with high positive correlation and high negative correlation values for the input features, except the diagonal value 1. Again, the matrix where correlation is found, and then unstack it, and then find the positive and the negative correlation from the correlated pairs. Now, ninth question, display the feature pairs that have correlation value greater than 60% for the given input feature. So, in order to find that, use np.abs absolute value of the correlation pair and greater than 0.6 in order to get the correlation pairs greater than 60%. 10th question, analyze the skewness of the feature using plot distribution graph for the tax column and declare whether the feature is right skew, left skew, or no skew. Using the plot, and it's clearly mentioned it is tax column is right skew, and the skewness value is 0.3485. And then coming to the 11th question, perform univariate analysis for categorical variable city using bar plot with counts of observations. So first, again using the PLT pie plot the graph. It's a bar graph which shows the univariate analysis for categorical column. Then perform univariate analysis for continuous variable rating using swarm plot and violin plot. Again, it's plotted. This is the swarm plot, and this is the violin plot. 13. Display the scatter plot to show the relationship between two continuous variables, tax and cox. And again, the, the graph is shown here. And next question, perform bivariate analysis between categorical variable and continuous variable of gender and age using categorical box plot. Again, it is shown here using code. And again, 15, perform a bivariate analysis between two categorical variables, gender and customer using crosstab and count plot. And again, uh, we need to find the member and normal of both female and male and then plot a bivariate graph. We will have two variables and it is plotted here. And at last, for part A, is a multivariate analysis, which will be having like more than two variables. So here the variables are age, price, tax, ratings, and costs. And Q is taken as city, which is the color that you are seeing here in this picture. And coming to part B, again, load the second data set to perform the pre-processing. And the 17th question is identify the column with null values and calculate percentage of missing values in the columns. So eastnull.sum is used to find the missing values, and the missing percentage is calculated by using mean into 100. And coming to the 18th question, replace missing values with mean of the numerical column if the percentage of missing values is less than 10. Display eastnull.sum before and after imputation. So this is before mean imputation. So here we are doing mean imputation. And so we'll fill the missing values which is greater than which is less than 10 percentage using the mean of that particular column, and this is before and after the imputation. And 19th question is using the nearest method imputation to estimate the missing values if the percentage of missing value is less than 10 percentage. Again, before and after imputation. This one is the imputation of categorical data. If the percentage of missing value is less than 10 percentage, display is null, and before and after imputation. This is before imputation and this is after imputation. So drop the columns with more than 10% missing values and display the size of before and after dropping. The 21st question. So this is the size of the shape of the data set before dropping, and this is the size of the data set after dropping. Coming to the next question, drop the rows with outlier search score greater than 3 for quantity and display the size before and after dropping. Here, dropping rows with outliers that score value greater than 3. That is on in this code, and this is the output I have got. And coming to the next question, it is find the percentage of the duplicate rows with all columns having same values. Here I use df.duplicated of mean into 100 to find the percentage of the duplicated values. And coming to the next question, drop the duplicates and display the size before and after dropping. And the code is here, which drops the duplicate using drop duplicates. And yeah, before dropping it's 51 comma 15, and after dropping it's 49 comma 15. The next question is find the percentage of duplicate rows based on some specific columns having high values. So these are the columns that I took, and then the duplicate percentage is found using duplicated function of the particular columns that I had taken before. And the percentage of it is found using mean into 100. And the next question is drop the duplicates and display the size before and after dropping. So here again, before dropping the duplicate and after dropping the duplicates using the drop duplicates function as I did it in the previous question, that is 24. And then the 27th question is perform the min-max normalization for a numerical feature age using Python code and analyze the values in scatter plot. The normalization is found using the formula age minus age dot min function by the age value dot max function minus the age value minimum age value. And scatter plot is plotted as per the normalization, min-max normalization. Then perform search score normalization for numerical feature age using Python here. Stats.setScore function is used to find the set score normalization, and plot is plotted. Graph is plotted. And then 29th question is to perform label encoding for a categorical feature Python for a payment using the Python code. It is label encoded using the label encoded function, and it is label encoder dot fit transformer. So it encodes all the categorical values in the payment column and perform one hot encoding for a particular categorical feature payment using Python code. Here also the one hot encoding is performed using concat function and the EFN code of PAT.get dummies of payment, and that is all about experiment number one. Thank you.